today we'll be looking at reactions of alcohol. Okay, so first of all, we have talked about the structures of alcohol. You should know we have primary alcohol, secondary alcohol, and tertiary alcohol. Okay, so and we also looked at the physical properties. Okay, talked about the boiling point of alcohols are very high with respect to their corresponding hydrocarbon as a result of what? Hydrogen bonding. So today we'll be looking at the chemical properties. When we talk about the chemical properties of alcohol, we are looking at the reaction. Where the reactions, or what kind of reactions does alcohol undergo? First of all, remember that alcohols are saturated. I hope you know that. They are saturated because of what? They have carbon to carbon single bond around them. And the carbon atom that has the OH group is sp3 hybridized. So because of that, alcohols are saturated. And remember that every saturated hydrocarbon must undergo what we call substitution reaction. So alcohol undergo, like, the main reaction of alcohol is a nucleophilic substitution reaction. There are other reactions that can happen, okay? There are other reactions that can happen, such as oxidation and the rest of them. But the key reaction involving alcohol is substitution reaction. Now, alcohol can be said to be amphoteric. Okay, let's start from there first. Alcohol can be said to be amphoteric, can behave as an acid, and at the same time it can behave as a base. Right? Now, that's what we said is what is amphoteric. So, in terms of the acidic behavior, let's look at the acidic behavior of an alcohol. In terms of the acidic behavior, alcohols can react with an acid such as H2SO4 to form OSO3H plus water. Okay? Plus water. So this reaction is a reaction forming what we call sulfonic acid, or the sulfate group here, or the sulfonic acid group here, right? Now, as a base, the basic behavior. Alcohols behave as a base by reacting with a base such as sodium amine. For example, alcohols can react with sodium amine. Okay? When reacted with sodium amine, it is going to form an alkoxide. Alkoxides are RONA plus ammonia. Right? So this is the behavior that alcohols, or the kind of reactions they can undergo, which makes them to be what? To be amphoteric. Now, aside amphoteric behavior or acidic behavior and basic behavior of an acid, alcohols undergo key reaction we call esterification reaction. So number 3, let's talk about number 3. Number 3 reaction of alcohol is esterification reaction. Okay? Esterification reaction simply means the reaction of an alcohol with an acid, an alkanoic acid, in the presence of a catalyzed mineral acid to produce an ester. So when you have an alcohol, ROH, and you react it with an alkanoic acid, RCOOH, in a reversible reaction where the forward reaction is catalyzed by an acid such as H2SO4 or HCl. This reaction will bring about a reaction between this acid and the alcohol to produce an ester, RCOOR plus water. Now, how did you get RCOR? For the sake of clarity, let me use prime here. So you have prime here. Okay? So when you have RCOOH reacting with alcohol, what happens here is that the OH in the alcohol takes the H here to form the water, while everything here combines together to form this. So this is what we call an ester. An example of such reaction is when we use, let's say, methanol reacting with, let's say, ethanoic acid, okay, in a reversible reaction. What we're going to have here is simple. The OH and the H goes to form water. So we'll have, let's say, CH3, COO, then we'll have what? CH3 plus H2O. So at the end of this reaction, what is produced here is called methyl ethanate. Okay, so this is what we call esterification reaction. So the backward reaction is what we call hydrolysis of an ester. When you hydrolyze this ester, you get back the two components that gave this reaction. Okay, so now let's look at the next reaction. The next reaction we'll talk about here would be dehydration of alcohol. So that was number 4. Dehydration of alcohol. Dehydration. Now remember that when we say dehydration, we simply mean removal of water molecule, right? So when you remove water molecule from an alcohol, you get a product. Now this dehydration is of two phases. Okay, it can take place at high temperature or low temperature. So the dehydrating agent we use is concentrated sulfuric acid. So for this reaction, if I have something like, let's say we have an alcohol, ROH, undergoing dehydration with concentrated sulfuric acid in the presence of heat, applied heat at 170 degrees and above. 170 degrees and above. Okay, this dehydration will lead to the formation of an alkane. But if I have this alcohol undergoing the same dehydration using concentrated sulfuric acid at low temperature, let's say a temperature of 120 degrees C, at this temperature, this reaction will lead to the formation of ether, okay, or what we call alkoxy-alkane, okay. So now let's perform this reaction and see how the reaction works. Okay, for example, if I have methanol, let's say I have methanol, CH3CH2OH, and we have our concentrated H2SO4 at high temperature of 180 degrees C, for example. At this reaction, there will be a dehydration. OH will go out and one of the H from here will also leave. So there will be a double bond between these two carbons. So when you remove this OH and remove one H from here, what you are going to be left is CH2CH2. So you're going to have CH2CH2. So because you have removed OH and H, you insert a double bond inside this place. So this reaction leads to the removal of what? Water molecule. Water molecule is eliminated from this reaction. Okay? But if I have CH3CH2OH, this same reaction, at a low temperature, let's say we have concentrated H2SO4. At a low temperature, let's say you have a temperature of 140 degrees C. This reaction will lead to the formation of an ether functional group. So what will happen is that this alcohol, two molecules of this alcohol will react. How? You have CH3CH2OH will also react with HOCH3 Notice that I repeated these two things. It's the same thing. So what happens? Water will be eliminated from this guy. Okay? So when you remove water from this guy, you join the remaining molecules. You have CH3, CH2O, CH2, CH3. So look at this reaction. What happens here is the ethanol reacts with itself, okay, to eliminate this water molecule. So what you have here is what we call diethyl ether. While what we have here is what we call ethane. So look at this dehydration. This dehydration is occurring at two different conditions. At a high temperature, at a low temperature, forms alkane, forms ether. And this is called diethyl ether, or you can call it what? Ethoxyethane. You can call it ethoxyethane. Okay?